Hello everybody and welcome to another masterclass. In this second lesson on polynomials, we'll learn to identify a polynomial and its different types. We'll also learn to find out the degree of a polynomial and convert a polynomial from one form to another. Before we begin this lesson, let us have a brief recap of what we have learned so far. In the previous lesson, you have learned how to identify a polynomial and its types, know what are like terms and unlike terms, state what is the degree of a polynomial, and convert a polynomial from one form to another. In case any of the above points are not clear, please go back and watch the previous video again. In this lesson, we'll learn how to solve some typical problems based on the knowledge you have gained so far. Typical problems in this section include how to identify whether an expression is a polynomial, to write a polynomial in standard form, index form, or coefficient form, to identify the degree of a polynomial and of a term, and to identify the different types of polynomials. The first type of problem we'll learn is how to identify whether an expression is a polynomial or not. Question 1 asks us, are the expressions given below polynomials? Explain. The first expression given is x minus 1 upon x. This expression is clearly not a polynomial, so we write it's not a polynomial. Since the question asks us to explain our answers, we have to justify our answer. Therefore, we can write the second term is equal to 1 upon x, which is equal to x to the power of minus 1. Since this exponent minus 1 is not a whole number, this is not a polynomial. Let us now take a look at the second expression, which is 3 plus root y. This expression is also not a polynomial, so we write it's not a polynomial. The reason for this is that the second term, which is square root of y, is equal to y to the power of 1 upon 2. Since this exponent 1 upon 2 is not a whole number, this is not a polynomial. We will now see another expression, namely y squared plus 5y minus 7. Very clearly we can see that this is a polynomial because the exponents are whole numbers. So we write it's a polynomial. The next expression given is 3p raised to the power of minus 2 plus 4p minus 5. This expression also is not a polynomial, so we write it's not a polynomial. The reason is because the first term is 3p raised to the power of minus 2. Since this exponent minus 2 is not a whole number, this is not a polynomial. The next expression given is 7. This is clearly a polynomial. 7 is a constant and all constants are polynomials. 7 is equal to 7x raised to 0. Since 0 is a whole number, it is a polynomial. This type of polynomial is called a constant polynomial. We now come to another type of question where we are asked to identify the coefficient of particular terms of a polynomial. Question 2 reads as, write the coefficient of x square in each of the given polynomials. The first expression given is 5x square plus 15x. If we observe the term 5x square, we will see that the constant 5 is multiplied by the variable x square. Therefore, the coefficient of x square is 5. The second expression given is 3x square. If we observe the term 3x square, we will see that the constant 3 is multiplied by the variable x square. Therefore, the coefficient of x square is 3. The third expression given is 6x raised to the power of 4 plus 9x cube. Since there is no term in the given polynomial with x square, its coefficient is 0. The given expression can be written as 6x to the power of 4 plus 9x cube plus 0x square. If we observe the term 0x square, we will see that the constant 0 is multiplied by the variable x square. Therefore, the coefficient of x square is 0. The next type of question in this section is to make polynomials of the specified type. These type of questions are open-ended and there may be many correct answers. Let's look at the first one, which asks us to make a monomial of degree 5. Two possible solutions are 3x raised to 5 or x raised to 5. Both these terms are of degree 5 and they are monomial. We could have used any other coefficient and any other variable. since the question does not specify anything about the coefficient or about the variable. The next question asks us to make a binomial of degree 9. Again, many solutions are possible. The only thing we have to ensure is that there are only two terms in the polynomial and that the highest degree is 9. The degree of the other terms are not important and neither is the coefficients of any term. So some solutions are 6x raised to 9 minus 7x raised to 4 or x raised to 9 plus 5x raised to 5. The next question asks us to make a trinomial of degree 95. We must ensure that the highest degree is 95 and that there are three terms in the polynomial. The degrees of the other terms and the coefficients of all the terms are not important. So some solutions are 8x to the power of 95 minus 7x raised to 4 plus 11 or x raised to 95 plus 5x raised to 35 plus 53x raised to 5. The next type of question asks us to identify the degree of polynomial. The first polynomial that is given is square root of 3. In this polynomial we do not see any variable. However, if we rewrite this polynomial as root 3 x to the power of 0, we can understand that this is a polynomial of degree 0, or in other words a constant polynomial. So the degree of this polynomial is 0. The next polynomial given is x raised to the power of 0. Here it will be seen that a variable is mentioned with exponent 0, since x raised to 0 is equal to 1 and since 1 is a constant, this is a constant polynomial and its degree is 0. The next polynomial given is x raised to 5 plus 6x raised to 9 minus x raised to 4. Here the highest power of the variable is 9. Therefore, the degree of this polynomial is 9. The next polynomial is x raised to the power of 19 plus 5x raised to 5. Here the highest power of the variable x is 19. Therefore, the degree of this polynomial is 19. The next polynomial given is root 3 x to the power of 5 minus 7x raised to the power of 4. Here the highest power of the variable x is 5. Therefore, the degree of this polynomial is 5. We now come to the last polynomial, which is 7x raised to 4 y squared z raised to the power of 5 plus 11x cubed y squared z squared. This polynomial has variables in x, y and z. To find the degree of this polynomial, we must find the term in which the sum of the exponents is the highest. In the first term, if we add the exponents of the variables x, y and z, we get 4 plus 2 plus 5, which is equal to 11. In the second term, if we add the exponents of the variables x, y and z, we get 3 plus 2 plus 2, which is equal to 7. The sum 11 is the highest in the first term. Therefore, the degree of this polynomial is 11. In the next question, we are asked to group polynomials according to whether they are linear, quadratic or cubic. The first polynomial that is given is 3x squared. The degree of this polynomial is 2 and hence it is quadratic. The next polynomial given is 5y squared plus 6. The degree of this polynomial is also 2 and hence it is also a quadratic polynomial. The next polynomial 8x plus 3. In this polynomial the degree is 1 and therefore it is a linear polynomial. The next polynomial z squared has a degree of 2 and hence it is a quadratic polynomial. The polynomial 13x cubed plus 3x squared has a highest degree of 3 and hence it is a cubic polynomial. The polynomial 5y cubed plus 6 also has a degree of 3 and hence it is a cubic polynomial. The polynomial 2x cubed plus 4x squared plus 7x plus 3 has the highest degree of 3. This too is a cubic polynomial. The polynomial 5x squared plus 15 has a degree of 2 and hence it is a quadratic polynomial. The polynomial 5y plus 6 is a linear polynomial since the degree of this polynomial is 1. The degree of the next polynomial 9x plus 1 is also 1 and hence it is a linear polynomial. The next polynomial given is 6z cube minus z square plus 4. The degree of this polynomial is 3 and hence it is a cubic polynomial. The polynomial 6x square plus 8x has a degree of 2 and hence it is a quadratic polynomial. The last polynomial given is 8x. This is a linear polynomial since the degree is 1. The next type of question asks us to write a polynomial in standard form. To write a polynomial in standard form, we must write it in descending order of the exponents. Therefore, x squared plus 7 minus 4x must be written as x squared minus 4x plus 7. The polynomial 3 plus 7x plus 2x cube plus 4x squared must be written as 2x cube plus 4x squared plus 7x plus 3. The polynomial x raised to 5 plus 6x raised to 9 minus x raised to 4 must be written as 6x raised to 9 plus x raised to 5 minus x raised to 4 to make it in standard form. The polynomial 15x minus 5x square must be written as minus 5x square plus 15x to make it in standard form. The polynomial 5y minus 7 plus y squared must be rewritten as y squared plus 5y minus 7 to make it in standard form. The last polynomial 13x raised to 4 plus 3x raised to 5 minus x raised to 6 must be rewritten as minus x raised to 6 plus 3x raised to 5 plus 13x raised to 4 to make it in standard form. In the next question, we have to write the polynomial in the coefficient form. To write a polynomial in the coefficient form, we must first arrange the polynomial in descending order of its exponents. We must now write the coefficients in brackets separated by commas. If any term is missing, we must write 0 in its place. The first polynomial given is x square plus 7 minus 4x. To write this in coefficient form, we must write 1, minus 4, 7. The polynomial 3 plus 7x plus 2x cube plus 4x square becomes 2, 4, 7, 3 in coefficient form. The polynomial x raised to 5 plus 6x raised to 9 minus x raised to 4 must be rewritten as 6, 0, 0, 1, minus 1, 0, 0, 0, 0. It is now in the coefficient form. The polynomial 15x minus 5x square must be written as minus 5, 15, 0 to make it in coefficient form. 5y minus 7 plus y squared must be written as 1, 5, minus 7 to make it in coefficient form. The last polynomial given is 13x raised to 4 plus 3x raised to 5 minus x raised to 6. This must be written as minus 1, 3, 13, 0, 0, 0, 0. It is now in coefficient form. It will be seen from the above that if the degree of the polynomial is n, then there will be n plus 1 terms in the coefficient form. For example, the degree of the last polynomial was 6 and therefore there were 7 numbers in the coefficient form. In the next question, we are going to do the reverse of what was done in the previous question. We are given a polynomial in coefficient form and we have to write it in standard form. The first polynomial given is 3, 1, minus 4, 7. This must be written as 3x cube plus x square minus 4x plus 7 to make it in standard form. Polynomial which is indicated by the coefficients 2, 7, 3 must be written as 2x squared plus 7x plus 3 to make it in standard form. The next polynomial given is 6, 0, 0, 0, 1. This must be written as 6x raised to 4 plus 1 to make it in standard form. The polynomial minus 5, 1, 0, 5, 0 must be written as minus 5 x raised to 4 plus x cube plus 5x to make it in standard form. The polynomial minus 1, 5, 0, minus 7 must be written as minus x raised to 3 plus 5x squared minus 7 to make it in standard form. The last polynomial given is 1, 3, 3, 1. This must be written as x cubed plus 3x squared plus 3x plus 1 to make it in standard form. It will be seen that if there are n numbers in the coefficient form, then the degree of the polynomial is n minus 1. For example, if there are 4 numbers in the coefficient form, then the degree of that polynomial is 3. In the next question, we are asked to sort polynomials according to their types, that is, whether they are monomials, binomials or trinomials. Further, the polynomials could be linear, quadratic or even cubic. It must be noted that a polynomial which is linear, quadratic or cubic could also be a monomial, binomial or a trinomial. The first polynomial given is 5x squared minus 3. It will be seen that there are 2 terms in this polynomial, so it is a binomial. Also, since the highest power is 2, it is a quadratic polynomial. Therefore, this polynomial 5x squared minus 3 must be classified as a binomial as well as a quadratic polynomial. The next polynomial is 5y minus 7. Since there are 2 terms in this polynomial, it is a binomial. However, in this case, the highest power is 1, therefore it is a linear polynomial. Therefore, the polynomial 5y minus 7 must be classified as a binomial as well as a linear polynomial. The next polynomial is x cubed plus x squared minus 4x. Since there are 3 terms in this polynomial, it is a trinomial. The highest power is 3 and so it is a cubic polynomial. Therefore, this polynomial x cubed plus x squared minus 4x must be classified as a trinomial as well as a cubic polynomial. The next polynomial is 3x cubed. Since there is only one term in this polynomial, it is a monomial. The highest power is 3 and so it is a cubic polynomial. Therefore, this polynomial 3x cubed must be classified as a monomial as well as a cubic polynomial. The next polynomial is 3x. Since there is only one term in this polynomial, it is a monomial. The highest power is 1 and so it is a linear polynomial. Therefore, this polynomial 3x must be classified as a monomial as well as a linear polynomial. The next polynomial given is x cubed plus 5x squared minus 7. Since there are 3 terms in this polynomial, it is a trinomial. The highest power is 3 and so it is a cubic polynomial. The next polynomial is 2x squared. Since there is only one term in this polynomial, it is a monomial. The highest power is 2 and so it is a quadratic polynomial. Therefore, this polynomial 2x squared must be classified as a monomial as well as a quadratic polynomial. We have now come to the end of the lesson in which we have learned how to solve some typical problems related to polynomials. Time for a quick recap of what you have learned so far. To identify whether an expression is a polynomial, to write a polynomial in different forms, to know the coefficient of a term, to identify different types of polynomials. In case any problem is not clear, please watch the video again. We have now come to the end of this lesson. In the next lesson, we will learn how to do different operations on polynomials like addition, subtraction, multiplication and division. To watch other videos, please click on the playlist. To visit the masterclass channel, click on the round logo. Don't forget to subscribe and also ring the bell to be notified immediately when a new video is uploaded. Thank you for watching this video.